it's Dan. Recently, I ran some workshops for Monome to help introduce folks to scripting on Norns, our computer designed for sound. The focus of the workshops was modifying a script called First Light, which is available through Maiden's project manager. First Light's dope. It's comprised of a when mechanism, which blows against a set of chimes. The chimes are just a synth engine that's running on the Norns through SuperCollider. There's also a delay, which uses a sampling engine that's built into Norns called softcut. I had a lot of fun with these sessions, so I figured I'd share the recordings so that you could dig in. The only real prerequisites are to get your Norns on a Wi-Fi network and downloading the script through Maiden. The content is split into sections. First, we'll live code the sound engine, we'll change softcut's parameters to warp the delay, and we'll overwrite some of the script's default values and interactions to make our own custom version. We'll be running more of these workshops live in the future, so to stay up to date, visit LLLL.co. That's 8ls.co, and look for the First Light thread. I hope you enjoy this video, but most of all, I hope you have fun experimenting. You'll notice when we load the script, some stuff prints to matron. So just kind of going through this list, Norns script load, we loaded the script, so it's letting us know this is the script that got loaded. It cleaned up the last script that was running, cleared it, and then started running our new script. There are two major components to every Norns script. There is the Lua code, which is this section here. It defines the interactions. It sets up parameters. That's the control layer. The synthesis layer is SuperCollider. And you'll actually notice that there are two tabs inside of this REPL area. There's a matron REPL, but then there's also a SuperCollider REPL. And this will report on the state of the synthesis layer of Norns, which is SuperCollider. For this session, we're not going to dig too much into the SuperCollider thing. What we will do, though, is manipulate the SuperCollider engine using commands and the functions that are built into the script, which communicate directly to the synthesis layer. When a script with an engine, a synth engine, loads, it will tell you what the available commands are for the engine. So amplitude will be the loudness of the synth. The cutoff is going to be the filter cutoff frequency. Gain is going to be the filter gain, so you can kind of tweak a resonant frequency. Hertz is which note, essentially, in hertz we'll hear. Panning, just across the stereo field. Pulse width, which will make sounds kind of like sharper and more like strings. And then release, which is how long after the initial note event should the note ring out for before it's ended. So let's just dive in to scripting this engine with live code. I'm going to turn off the sequencers on the Norns. So K2 will turn off the little like delay that we've been hearing. It'll stop that from moving around, so it'll just be fixed. I'm also going to turn off the wind by hitting K3. Nice. Silence. Let's start making some notes of our own. I'm going to directly address the engine that is currently loaded, which is called PolyPerc. It's just a synth engine that Brian made when he was first trying to learn SuperCollider for the Norns project, and it's the one that has stuck. So I'm going to directly address the engine. I'm going to put a period after that engine, and I'm going to choose one of these commands to address. The easiest one to start with is Hertz, because that will basically be like a note at this frequency. So engine.hertz. And then every function has parentheses. Inside of those parentheses, you can pass an argument to the command hertz. So I want to pass 700 to the hertz command of the engine. Sound happened. If I press the up arrow on my keyboard while I'm in this little command line, it'll reload the last thing I executed. Nice. We're just making some synth sounds. And I really like this kind of like dividing, right? Like math is such a heavy component of music that I don't necessarily have to know which harmonically sound frequencies to choose. All I have to do is like divide or multiply. I can even do weird ones. Let's say 1.25. Nice. 1.5. 75. Let's start addressing some of these other commands because I've made some notes, but I might want to change maybe like the way that the notes sound, the timbre of it. It's going to be by changing the cutoff of this engine. So let's say, all right, engine.cutoff. Now this is going to be a filter. So it's a range between 0 and 12,000 hertz. So I'm just going to choose a number in between that. Let's see what we get. And I'm going to pass it another note, hertz. Nice. That filter opened up. It changed the timbre. Say I want to change that cutoff again. I kind of hate doing this like, okay, change the cutoff, and then I have to like pass a note to kind of hear what's happening. I can execute multiple commands in the command line by just separating them with a semicolon. So if I were to say, all right, change my engine cutoff to 1,000 and play a note at 450 hertz. Yeah, the division stuff is really neat. There's this music and mathematics Wikipedia article that just has straight up how to use ratios to get notes. So like if I wanted a major third from 500, I would just do major third is 5/4. So I want to multiply this by 5/4. Let me play 2 at the same time. This is pretty fun, right? We can kind of sequence chords with this like semicolon stacking thing and using this ratio breakout, a minor sixth. I don't know what this will sound like, but we'll see what happens. That is 500 times minor sixth, 8/5. Let's try some other ones, right? So release, right? Let's try engine.release. I don't know. It's in seconds, so maybe 2 seconds. Let me change that cutoff so I can hear it better. What happens if I go really small? Ooh, that's fun. Just a little blip of a note. So I'm going to give you guys a few minutes here. Let's just do maybe like 2 minutes to dig around with just these 3, right? Engine.cutoff, engine.hertz, and engine.release. And see where you get to and make note of like maybe some fun ones that you'd like to save. Now's a good time to take a few minutes and experiment. I don't know about y'all, but I found I like the engine cutoff to be a little bit more open. I like the sounds to be a little sharper, and I want my release to be much shorter. I want these little plucky tones, and I want that to be the default of the script. So we're going to edit the actual script itself, right? We've been using these engine.cutoff, engine.release, engine.hertz. Those are going to be the same exact building blocks that are hard-coded into the script. So, for example, if I search for engine.cutoff, there's only one result, and I was able to do this using Command F or Control F. Engine.cutoff returns one result right here. And here we've got our little robot friend letting us know this is actually a good place to mess with the code. So I'm going to change this for myself. I like 9,000. You should change it to whatever you like. If you want it to be halfway. I also want to change the release. And all these are kind of stacked in a neat little stack. I want this release to be way shorter. I want that to be 0.2. I didn't mess with pulse width at all. Let's see what happens if I change it, though. So make some changes to this section. You can save the script using Command S or Control S, or by clicking the little floppy disk. That saves your change, and then we'll reload the script using Command P, Control P, or run script, this little play button. All right, we've done some stuff with the engine. I kind of want to start messing with softcut. I'm going to just play notes by hand. So engine.hertz, 500, cool. And you hear right now that softcut is configured as just like a mono delay line. It's pulling in from the engine and it's repeating it back to us. This is just 1 out of 6 voices of softcut at work. And we're just going to focus on the one, but there's some cool things that we can do. So the first thing I want to do is mess with how long this repeat goes for. So if I play a note, you hear it kind of trail off. That is going to be a parameter of softcut called pre_level. And what that does is it controls how much of the already recorded audio persists every time the record head goes over. So it's just turning up the feedback on a delay. 0 to 1 is the range we want to stay in. So if I turn it down to 0.2 and play a note, whoop, I got a bad argument. I messed up somehow. Softcut has 6 voices. I didn't tell Softcut which voice I want to have this pre-level of 0.2. So I have to specify voice 1, separate it out with a comma, and say 0.2 to this one. So if I execute that, we're good. So yeah, we're starting to get into multiple arguments to a function, right? Previously, we were just doing one argument, right? Engine.hertz and then one number. Softcut, because there are 6 voices, we have to specify which voice, and then we can pass the argument to that voice. Let's see what 20% feedback sounds like. Cool, much shorter. Let's crank it, say 9.9. That's 99% feedback. Now it's staying. It'll eventually trail off, but it is set so high that it will take a while. I'm actually gonna crank it up to 100%, so 1. I want audio to be retained in the buffer. I'm gonna do another couple of notes in here. I've got this like chord stacked inside of softcut. It's just got this audio. Kind of want to do something with it. I'm going to slow down the rate of playback. Again, I want voice 1, and I'm going to slow it down to half speed, 0.5. Such a satisfying thing. Let's make it slow as hell. Slower. Yeah, I like this, right? Tyler zoning. This is a zone. Yeah, hell yeah. I can put another note in here. And you'll notice that that new note isn't at that slow pitch, right? It's just at what it was when I entered it. And that's because the read and write heads are coupled by that speed. So if it's writing at the same rate that it's reading, then it's going to play the note the way it was played. If I were to slow this down even further, though, divided by 2, then it drops down. I can also go in reverse. So by passing a negative value, I can go higher. Weird stuff. Sorry. I'll stop. 0 is stop. The two arguments that we use softcut dot pre-level for voice 1, and we use softcut dot rate. So the way I like to do it is to turn up the pre-level of voice 1 to 100%. So just pass it 1. That means no past audio will be lost. And then I can just start feeding notes into softcut by executing engine.hertz, and I can stack chords and things like that, and they'll just all shuffle in there. And then once you got something cool, start messing with the rate. Now's a good time to take a few minutes and experiment. So I kind of just want to spend a little bit of time talking about the code of what we actually see and what we interact with as performers. So the first one is going to be the chimes, right? So when I press K3, that turns on the wind. And when the wind blows, it plays my chimes. That state is just called chimes. And if I enter chimes in Maiden and I execute it, Maiden's like, well, this isn't like a function. This isn't, addressing softcut. This isn't addressing the engine. This is actually just a variable in the script. And it tells us that the chimes are either on, or if I turn them off, or the chimes are not on. So the chimes are either true or they're false. It's just a strict Boolean. So if I say well, all right, chimes equals true, then the script turns on the wind because that's the thing that makes the chimes. If I say chimes equals false, when we look at the script, it kills the wind because the wind's what's making the chimes and I don't want the chimes. So this is like a programmatic thing that we can do, right? Like it's a variable that causes changes within what we're hearing from the script. Instead of doing this kind of like up to turn on and up to turn off by re-evaluating chimes equals false, chimes equals true, chimes equals false, chimes equals true, you can also just say chimes equals not chimes. And what this does is it says, well, what is the state of chimes? Whatever that state is, I want it to be the opposite. So chimes not chimes, when chimes is false, turns it on. Chimes not chimes when chimes is on, turns it off. This is just like a really kind of like goofy little logic thing, but it actually saves a couple of moves, right? Like I'm never going to turn it off twice. I'm either going to turn it on or turn it off. So instead of like executing chimes equals true and then being like, okay, chimes equals false, just say chimes not chimes. I also know that K3 does this same thing, right? So I'm going to search in the script for where the keys happen. And this is actually really a standard interaction for all Norns scripts. Every single script you touch, if it has an interaction tied to the keys or the encoders, there's going to be a section of the code that is literally function key. It's going to have two arguments, N and Z. We'll figure out what that means in a sec. If I go through, right? If N equals 3 and Z equals 1, then chimes not chimes, which is what I've been doing here, right? So chimes not chimes, I know is tied to K3. So there's my 3. And then Z equals 1, I know that if I press K3, chimes not chimes happens. If I release K3, it doesn't change the state of chimes. I have to press it again to chimes not chimes, and nothing happens when I release. So the 1 is actually a direction. It's down for 1, and up is 0. This is standard for every single Norns script. So if you wanted to hack something and say, like, you know what, I want to change what key 3 does, then you would just look for this bit of code and say, like, all right, N equals 3, Z equals 1, that's a down. Chimes not chimes. I want to make something happen when I release the key, though. So let's add some stuff to the script. So I'm going to say else if N equals 3 and Z equals up 0, then do something else. Maybe change the engine cutoff, right? Let's see what happens. So I know my script's engine cutoff is at like 9,000. So let's say when I release K3, I want the engine cutoff to change to 4,000. So I'll press it, release. Because I've released, engine cutoff should now be 4,000 instead of 9,000. There it is. The engine cutoff changed because I attached it to this key 3 release. But it only changed once. It just changes to 4,000, right? Like there isn't like other numbers here for it to change to. So I think it might be fun to do something random, right? Like it's kind of a fun gesture to be like, all right, every single time I like turn this thing on or off, I want the cutoff to be a different frequency so that the next batch of sounds different than the last batch of sounds. So Lua, the scripting language, has some really cool math functions built into it. One of those is math math.random. And this is a function. So if I execute math.random, it does something, right? It prints random numbers. As I'm doing it, though, I'm realizing that it's only doing like numbers less than 1, right? They're all decimals. They're all floats, and they never go over 1. Engine cutoffs, that's not going to do anything, right? Like an engine cutoff needs to be between 0 and 12,000. So doing random numbers less than 1 isn't going to get me anywhere. Here is where I would typically like Google some shit. You know, I know that math.random exists, and I know what I want, and this isn't giving me it. So there's got to be something, right? So I'm just going to random numbers greater than 1, right? Lua. Dope. A math library tutorial. Sure, why the hell not, right? All right. Oh, I know I want random. Okay, random. Cool. Math.random, blah, blah, blah. Ooh, sweet. The actual Lua documentation actually has some really neat stuff about math.random. So there's math.random with no arguments, generates a real number between 0 and 1. Math.random with 1 argument generates integers between 1 and that argument. And then math.random with 2 arguments generates integers between the 2 arguments. So let me try some shit, right? I know that my maximum is like 12,000. So what happens if I do math.random 12,000? 52. Oh, okay. Dope. These are going to be useful for my filter cutoff. I don't necessarily want it to be super low though, right? Like 163 is probably not even going to make a sound. It's going to be too muffled. So I'm going to use that 2 argument version to set a boundary. So maybe I don't want it to go lower than 1,000. And I don't want it to go higher than 12,000. So now when I execute some of these, I should not see any numbers less than 1,000. So I'm just going to copy and paste that. And I'm going to get rid of this 4,000 because that's fixed. I'm just going to paste in a random one so that every time, the way that, you know, if this works, then my engine cutoff should change between 1,000 and 12,000 every single time I release K3. Let's give it a go. So turn off the synth, turn it on. Those first 2 were kind of the same. There we go. Now it's different. And this could be something besides the cutoff, right? Like I could change the release, and I would maybe want to give it smaller numbers than 1,000 seconds and 12,000 seconds. But like if I did engine dot release, and then maybe I want between 0 seconds, or no, right? I liked that regular old math.random gave me between 0 and 1. That'll be nice for the way that I like my engine release. Cool. So I would encourage just like messing with some random values for one of the engine parameters, right? We have engine dot release, engine dot PW for pulse width. We have engine dot cutoff. I'm gonna also mess with key 2 here. Let me actually like make a chord. All right, so engine dot hertz 800, engine dot hertz 1200, engine dot hertz 400. That'll probably all be the same note pretty much. But Now that I have like a couple of commands at my fingertips and I have like a hardware interaction, I could just completely redefine how the script works. So I load it and I press K2, then this chord happens because I said, yeah, if I'm pressing K2, then play these notes. Engine release changes, which is like kind of dumb, but it's also kind of satisfying to be like, I have a chord button now. That's my chord button. I can do the same thing with my randoms, right? I was doing the divided by numbers to get these like these undertones of the main pitch. So like I could say divide it by a random number between 1 and 6. You might also want to change some of the ways that things start up, right? Like if I don't want the chimes on at all when the script starts, then I just need to see where the chimes are being set to true. Maybe I want to set those to false at the start of the script. Maybe I want the sequence to be set to false at the start of the script so that it's just a blank slate and nothing is happening until I press buttons. So yeah, and using kind of like what we've had, like we can also use softcut, right? Like softcut.rate, maybe a random one, right? Math.random. Let's see what the hell happens there. Oh, right. I need to say softcut rate 1, voice 1. Now's a good time to take a few minutes and experiment. Sweet. Awesome. Home stretch. The notes that are playing as part of the chime, I'm going to just search for chimes. And if I search for chimes, I get Brian's nice annotations here that wind blows chimes play. I've got wind as a function. It's doing something. It's making light. There's a little robot friend, which means that there's something here we can edit. The thing we can edit is the notes. Now, the notes are using this kind of like bracket notation. This is new for everything that we've been doing, right? Everything we've been doing previously has been stuff like engine.hertz, like calling functions and using parentheses and passing arguments within those functions. We've also used stuff like variables, like chimes, and we've found that they are false or true. But this one's different. So notes is a table. And tables are actually a really powerful component of Lua. And they're conveniently a very powerful component of music intersecting, right? Like a spreadsheet and a score are very nearly the same thing. It's just data. And it is specific and organized, and it is presented to somebody who can interpret it. So a table in Lua is just going to be a container of multiple things that we want to keep track of. So for example, in my REPL, I'm going to create a basket. And I'm going to say that the basket is a table. And I'm just going to put a couple of things in here. So a couple of numbers, right? And I'm just going to separate them with commas the same way that a CSV is, right? Comma separated values. I'm going to execute this in Matron. It's not going to change anything about the script, but this exists now. So there are a few things that we'll want to kind of like a few concepts that we'll want to engage with about tables before we dig into them in the script. So basket has a few things in there. Create one for yourself. I can see how many things are in the basket by executing this pound sign and saying basket. So I want to know the number of things in basket. Tells me there are 4 things in the basket, which makes sense because I said 67, 120, 45,300, 638, and 198 should all live in the basket. Those are 4 discrete values. Now, let's say I wanted to recall what the third number is. So I would use square brackets next to basket, and I would pass an index into there. So if I want to know which is the third value inside, the third value inside a basket, I can execute this and it'll tell me 45638, which is our third one. If I say basket 2, it'll be 120. If I say basket 1, it should be 67. This is like a huge concept, but it's a really cool and powerful one, right? Like I can contain multiple things inside of one variable name as long as I pass like, well, I want the third one, I want the second one, I want the first one. So that's what we're doing with notes. We have 4 note values that the chimes are doing something with, right? Like there's a ton of stuff in here. Some of it I recognize, math.random, engine.hertz, clock we haven't talked about yet. So there's like a few things that I recognize, but the main thing here is that the notes table is being passed to the engine as a Hertz argument. So here's a spot where I can completely redefine the notes. So once you redefine the notes, just Command S save, Command P play. Nice. My notes are now playing instead of the notes that were there. This is very organic. It is how wind moves, right? Like big gust, kind of nothing for a little while. Another big gust. There it is. Chimes, not chimes. The part that is controlling that, there are 2 clock functions. There are clock studies. I encourage everyone to go into clock studies. Clock is the Norns system clock. It is how the Norns understands time. So we have 2 functions. Clock sleep 0.1, which is a delay of 0.1 seconds. And then a clock sleep of a random number between 3 and 9 inclusive. And that's, again, seconds. So if I'm comparing these two, and the thing I want to affect is how often the wind blows. 0.1 seconds doesn't sound like the interval that the wind is going on. But like 3 to 9 seconds definitely sounds like the interval the wind is blowing on. So I'm going to try getting rid of this random number and just say, like, what happens if I say every 1 second? Let me change this to 5. Recompile. Oh, chimes, not chimes. I'm going to make my chimes true again. Okay. So we should get another one right about now. Nice. So now it's going every 5 seconds. So this controls the regularity of the wind. So that must mean this is controlling the distance between notes. So if I make this very, very tiny, what happens? It's like a strum. because it's saying there should only be 0.01 seconds between every note once they start playing. If I increase this 2 seconds between every note and start replaying notes every 5 seconds, this is lovely. It's just choosing a new note. Can we have variable clock, like different timings between notes? Hell yeah, we can. So I'll say math.random. And let's keep this one just math.random, right? Because math.random on its own figures out a number between 0 and 1, which seems pretty good for a distance between notes. Cool. Here's a fun thing. Let's say this is happening every 5 seconds, right? But I'm working with like a drum machine. And I'm like, nah, I want it to happen like on a 16th note. I want notes. That's where the other clock function, clock.sync, comes in. Clock.sync is connected to a quarter note beat. So it'll take whatever the clock BPM is, which we can get coming back around to params get clock tempo is right now 81. Let's say I want that to be faster. I want that to be 120. And I'll say, you know what? Sync every quarter note. I want my notes. Actually, no. You know what? Let's do this. Let's do the distance between notes. The time between notes makes more sense. Clock.sync. Every quarter note, I'll get a note. This thing is steady now. It runs out of notes, but every 5 seconds it reseeds notes. No more notes, but it'll reseed. So if I mess with this, let's say I make that a fourth of a quarter note, which is a 16th note. Actually, this is nice. So now my notes are 16th notes at the clock, because this is syncing a 16th note at whatever the clock tempo is. Let's say I want the restart to be pretty regular as well. So instead of clock.sleep, I'll say, you know what? Every 16 beats, seed the notes, and between the notes, there should only be a 16th. This is kind of like the jumping off point. Most scripts are just this. It's making decisions about how you want the notes to play, which engine you want them to play through, whether or not you want that to be synced to the Norns system clock, what should happen when you press a key, what should happen when you turn an encoder. These are the basic requirements of every single Norns script. Tables are the cornerstone. We could use tables to manipulate softcut rates if we want. Yeah, like softcut plus an engine is so powerful once you start incorporating tables into it. And they're just like Excel spreadsheets, right? It's just going down a list. Between those things, you end up with a really playable application, really playable script. And you can edit, like we just edited this one to be regular rather than Brian's beautiful wind metaphor. We still have the wind, but we're saying, I want the wind every 16 beats. I don't want it just whenever. These are the things that are like, they turn into feature requests, right? But there are also things that you can just do. If you have a performance need, you can crack into the code. That's the gorgeous thing about this, is it's all open source, right? It's what you're using is completely redefinable by you. You can absolutely swap out any of these fixed things and just say, yeah, I want it random, and I want it to be insane how big that random range is. You can make it very small and make it, discrete. We'll see y'all later.